Good evening. Good evening, everyone. I kindly request those who are standing to settle down. All right. It's been a long day, and this will be our last session. I want to thank you guys for the patience. So basically, in this last session, a lot of things are going to happen, but we'll start off with at least some papers being presented by members of the panel here. I have two panelists. I'll just request each of them to introduce themselves before the first panelist comes to present their paper. I'll start with Samuel.
Good afternoon, ladies and gentlemen. My name is Samuel Miruka, and I'm from Kenya. I am a core network support engineer at Safaricom. Safaricom is a telco and an ISP that operates in Kenya. Thank you.
Thank you, Samuel. Michelle.
Good afternoon, everyone. Michelle from South Africa. So I head up interconnection at peering at Terraco and NAP Africa. So Terraco is neutral co-location facilities and NAP Africa is the IXP. Thanks.
Thank you, Michelle. Can someone support to close that door there? There's a lot of noise coming from outside. Okay, we'll start off with Samuel. Samuel, kindly take the podium.
Thank you very much, Noah. I'm excited to be here with you. This is the first time I'm attending the AIS, and more so today to share with you my experiences with deploying IPv6 in mobile networks, if you like, cellular networks or mobile broadband networks. So we've done quite a bit at Safaricom, and from the lessons that I've gathered over the past 1.5 years, I hope to share with you and hope that those of you who are working with mobile operators across the continent can also take a step to deploy IPv6. So I would assume that many of us do understand the need to deploy IPv6, but there are some certain aspects of the technologies used in mobile broadband that will make it even crucial for you to begin to start thinking about deploying IPv6 sooner rather than later. We'll also see what will be required for you to successfully deploy your IPv6. And as with any other IPv6 deployment, be sure that you will meet some challenges. We'll discuss some of them, and we'll see how best you can go about them. And we'll actually try to ponder over some of the strategies that you can deploy after you have done an assessment of what you require to do on your network. So there are some specific things about mobile that will actually drive you to adopting IPv6. I can give an example, like when smartphones came into the market, smartphones are devices that are actually very hungry for connections. So we have devices that will require internet access even when you are not actually using them. So as long as you've enabled data on your phone, you can be sure that your phone has actually acquired an IP address that has been allocated to you by your ISP. And with the introduction of 4G and LTE, it makes it even more interesting. 4G is an exclusively IP-based connection, and as long as you are attached to a 4G network, you've occupied an IP address space. So regardless of whether you've enabled mobile data on your device or not, when you're on 4G, you've occupied an IP address. So this has actually driven the utilization even higher. Voice over LTE is a technology that uses IP for voice calls. So it moves away from the traditional circuit switch that we've been used to for so many years. So voice over LTE, with voice over LTE, you actually create an extra IP connection to connect to a voice proxy server. So if you're an operator or an MVNO who has the voice proxy server, known as the SBC, connected to the public cloud, then you might need to use public IP addresses. So if you're in a situation where you're allocating 2 public IP addresses for each user, your IP address utilization will increase. And lastly, Internet of Things. There was an excellent presentation about Internet of Things before lunch. And if we are going to connect all these devices, TVs, fridges, microwaves to the internet, the IPv4 address space is not going to be enough to connect all these people and all these things that are going to be connected to the internet in the near future. So once you've actually come to a point where you see that as an operator, you need to deploy IPv6, the first thing for you is to actually examine your architecture and understand what points within your network that you need to make modifications so as to support IPv6. So here I just have a sketch of a layout of a typical mobile network, very simplified. You have a database known as the home location register or the home subscriber server. So whatever I have in a brown font are the terms that are related to 4G LTE, the rest are related to 3G and 2G. So the HLR and the HSS is a database of the subscription of your SIM card. So it contains all the information about what you need to access in the network, and also it aids the core network in authenticating you as a subscriber. So part of this telecom subscription that is in the HLR or HSS is uploaded to the SGSN or MME. SGSN is serving GPRS support node, and MME is the mobility management node. So once this information is uploaded to the SGSN or the MME, the SGSN MME actually aids in creation of some sort of a tunnel between your phone and the GGSN or S gateway or P gateway. GGSN is gateway GPRS support node, and the term for 4G is a serving gateway or packet gateway. So once a tunnel is created between your phone and the GGSN, then the pipe that is created is known as a PDP context, and it's what allows you to get access to the internet. So the protocol that is in use to create the pipe is known as the GPRS tunneling protocol. And the pipe in 3G terms, it's known as a PDP context, and an evolved packet service bearer in 4G. We'll see how the creation of this pipe is important when we're talking about IP addressing for mobile subscribers. So once you've had a look at your architecture, you need to ask yourself, what are the features that are in these devices that you need to look out for? So most of these features are what you would expect to be given to you by your vendor out of the box. So it's not a matter of if the equipment has these features, it's just about you trying to find out how do you enable these features and how do you configure them. So the GGSN and the P gateway needs to be able to communicate with the IPv6 internet. And being the primary allocator of IP addresses, it also needs to be able to do that with IPv6 as it does with IPv4. Then the SGSN and the MME need to be able to support the creation of those pipes that actually allocate you the IPv6 sessions. The HLR, the HSS, the database that I've just talked about, needs to have the subscription information that indicates that you should create sessions that allow you to browse on IPv6. And most importantly, the mobile device needs to be able to work on IPv6 as well. So on this layout, where I have highlighted green, you just need the GGSN to have connectivity to the IPv6 internet through some form of routing, and you need to have your mobile terminal also supporting IPv6. So how you go about deploying, starting from the HLR or the HSS, you make sure that each of the subscribers in your network has at least some form of an IPv6 subscription record. Then at the GGSN and the P gateway, you define a large pool of IPv6 prefix. And from this large pool of IPv6 prefix, you allocate each mobile subscriber a /64 in a fashion that is similar to DHCP. So a /64 is a very big address space, and some of you might wonder why you need to allocate a single mobile subscriber as /64. But you need to remember that your mobile phone could be some form of a router doing, say, tethering, or you could just have a router dealing Cisco or whatever on 3G or 4G, providing internet access to its clients. And with IPv6, we are moving away from having routers doing NAT for internet access. You want your device to allocate a single IP address from the /64. So from the example of a phone, your phone will take one IP address and allocate the other IP addresses within the /64 to the rest of your clients. So it removes the need for network address translation that happens on these devices. So with this setup, you have basically enabled IPv6 on your mobile network, but you start facing some challenges. For example, you have an IPv6 only mobile network, and there are some servers out there in the internet which are only on IPv4. So as with many deployments, not just mobile, you'll find yourself needing to deploy NAT64 and DNS64. So this solution basically translates IPv4 packets, or rather IPv6 packets into IPv4 packets, and vice versa. You need a NAT64 gateway and DNS64 serving your client. So I won't go into detail in explaining how NAT64 and the DNS64 works because of the limited time that we have. I'd also prepared a slide just to show you how internet host without IPv6 is translated into an IPv6 address using a 96-bit IPv6 prefix. So it's just the concept is that the 32 bits of the IPv4 address are embedded into a base /96 prefix. And for those of you who are using DNS on Linux using bind, this is just how simple it is for you to be able to enable DNS64. You just define the /96 base prefix and the clients which you need the DNS64 server to actually serve. So we've talked about servers that are on IPv4 only. what about applications on mobile devices that at the moment do not support IPv6? I can think of Skype, for example. Skype on your mobile phone does not support IPv6 at the moment. And if you're using an IPv6 only network, you'll have a problem with such applications. So T-Mobile USA came up with an ingenious solution to create what they called a client address translation daemon. So what this daemon does is, as IPv4 packets come out of your application, they are translated to IPv6 before they leave your phone. And when these packets actually get to the network, they're translated back to IPv4 because these packets need to access some IPv4 server. So this has been a positive development. They submitted it to the IETF, and Google aptly adopted it as from Jelly Bean 4.3. So at the moment, I'm sure most of our Android devices are either on version 8 or version 9. So you can be sure that in your network, most of the Android devices do support 464 XLAT. So some other useful features that you will find in the network at the P gateway, there's a feature known as the dual address feature. So you can this is based on the assumption that if a device requests for a dual stack address, both IPv4 and IPv6, this is a device that can support IPv6 only. With 464 XLAT, and especially at Safaricom, this has been a safe assumption. And we are currently using this feature to avoid giving out IPv4 addresses which are actually getting depleted. So this is a very cool feature, and it will help you to accelerate your IPv6 deployment. So as well, looking at the SGSN, there are some SGSNs which you might have to activate a feature that allows the PDP contexts to be created using dual stack or even IPv6. Another cool feature with the SGSN or MME is an override. So like I'd mentioned before, you need the HLR or the HSS to upload subscription information to the SGSN. But you can also instruct the SGSN to disobey the HLR, and you can define a range of users or all the users or users of a particular network to have their subscriptions modified. So this has been important for us at Safaricom, especially because we have HLR, not HSS, but HLR, which does not have the option of subscribing for dual stack. It has only IPv4 and IPv6. So at Safaricom, we are playing it safe. We want subscribers to have the option of being able to select IPv4 or IPv6, but at the network, we prefer to allocate them IPv6 only. So let's speak about handsets. This is a screenshot from an Android handset. The Android handsets allow you to select what is called the APN protocol. So you can select, depending on whether your provider has enabled IPv6, you can select how you want to be allocated an IP address. So it's not just Android devices. There are some routers as well that allow you to select the APN protocol. We've had major success in trying to inform these device manufacturers to have, for Safaricom network, the default set to IPv4 and IPv6. So we noticed that the iOS for iPhones does not have such an option, and we've tried to engage Apple with regards to it. We don't have anything to show for it, but we hope they'll be able to make that consideration so that we can also have the iPhones using IPv6. So Operators, just trying to overcome the challenge on the previous slide, operators have a way of sending APN settings to mobile phones. And the challenge we have at the moment is that the OTA server that we have does not have a parameter setting that allows us to change the APN protocol to IPv4 and IPv6. So as up to this time, we haven't found a way to do it. I hope that very soon, if we find a way to do it, we'll be able to try it out and see whether we'll have these phones that are currently on IPv4 and we don't have a way of asking the subscribers to change it to IPv6, we'll be able to do it from the network side. So this would be a huge breakthrough. So speaking about some positives by some of the industry leaders, there was an announcement by Apple on June 2016 that all apps submitted to the App Store must be able to support IPv6. So I think that was a positive move. Apple and Windows have also joined in to support client address translation, like just like Android have done. And if you're deploying IPv6 and you're worried about NAT64, what you need to know is that the major content providers and most of the cloud providers have already enabled IPv6. So Facebook, Instagram, WhatsApp, Google, YouTube, and all that, they're all on IPv6. So we expect to see NAT64 declining and more servers being able to be reachable over IPv6. The backbone of your network, since mobile connections are purely based on tunnels, they're basically 6 to 4 tunnels. You don't need to worry about your backbone. If your backbone is on IPv4 or MPLS, or the communication between your GGSN and SGSN is IPv4, it's not necessary to have that change to IPv6 because it's irrelevant towards allocating IP addresses to subscribers. And all your network devices at the moment, sure about that, they support IPv6. So that would be the list of your worries. So this is just a summary of the setbacks I've just mentioned in the previous slides about phones that are still on IPv4 and the servers that are still on IPv4. They make the progression to IPv6 a bit retrogressive because it forces ISPs to invest in very expensive carrier-grade NAT devices in order for them to be accessible. So there's a website here, IPv6.watch. It's like a list of shame for all the big content providers, the likes of Skype, Amazon, that shows which ones of those have not still implemented IPv6. So as a security engineer, you need to appraise your knowledge on the threats that are apparent when IPv6 is involved. So when it comes to strategy, you just need to assess your architecture and see what works for you. You can decide to do what Safaricom has done, where we encourage users to request for dual stack, and then at the network we have the control of whether we will allocate them IPv4 addresses or not. You can also decide that you're going with dual stack, where you supplement the declining public IPv4 addresses with private IPv4 addresses, and then you deploy CGNAT. So this should not be your favorite way of going about it, but it all depends on your network. Just examine your network, see what works for you, and it's better to try one wrong way than not to try at all. So in conclusion, I think it's been discussed here. It's just going to be beneficial to us if we need to connect more people and more things. And especially because in this continent, the deepening penetration of internet access is on mobile. We need to look at the long-term sustainability of us expanding the internet connectivity, and IP addressing is something that is very crucial for us to have a look at. So at Safaricom, and I think for many providers, the fight at the moment is for us to have devices adopting IPv6 by whichever means that we can, and sensitizing the manufacturers to be aware that there are some networks that are supporting IPv6, and they should set their devices to be ready to access IPv6 right out of the box without having to bother users to go and change their settings and stuff like that. So I'm appreciative of this chance to share this much with you. And if there are any questions that you would like me to answer, please let me have them. Thank you.
Jody, 1 second. Right. We'll just take some questions, but some will have to answer after the second.
It's more than a question, it's a small clarification, very, very short.
Okay.
I have deployed already or helped to deploy IPv6 in about 15 cellular networks. And I just want to clarify a couple of points so that people don't get the wrong idea. 464XLAT is not a development of T-Mobile. T-Mobile was the first operator to implement it, but 464XLAT is an official ITF standard, okay? I don't recommend anymore anyone to just deploy NAT64 and DNS64. The way forward is 464XLAT in cellular networks and also in broadband networks. I can point later to anyone that has interest on it to a document that it's probably becoming an RFC. I am the author. It's about 40 pages explaining the deployment of 464XLAT in mobile and broadband networks. And one of the key things that you mentioned is Apple support IPv6, but you need to speak with Apple. You need to have your network ready. They will test it, and they will OTA allow the iPhones in your network to use IPv6. So it's just an administrative step, but it works perfectly. And the last thing is the CLAT implementation in Apple, it's only for the tethering. Why? Because Apple, as you well said, is supporting IPv6 only applications in the App Store since 2016, but they have also implemented Happy Evolves version 2 that actually is making for the applications built in the Apple, like for example Skype and others, to support as well IPv6 in automatic fashion, okay? So for the applications within the cellular phone, it's fine, they work, they are mandatorily supporting IPv6. So for example, Skype support IPv6 in Apple, otherwise will not be allowed to stay in the App Store. And for the tethering is where you have the CLAT. And that's it. Thank you. Anyway, I am here all the week. I am happy to help anyone willing to understand this better or having any additional questions. Thank you.
Thank you, Jody.
Thank you so much.
If there's any other question. Okay. All right.
It's not really a question.
Okay.
But somehow, what do you say for some operators who have many vendors, equipments in their network, and sometimes when they do the assessment, they notice that they have a lot of prerequisites to do before going for IPv6, but in the same time, we are in lack of IPv4 addresses. What is your suggestion for this case? Thank you.
Okay, there are some features that are standard to all equipment vendors, and these are standards that have been defined in the 3GPP. So if it's a standard that is defined in the 3GPP, you just need to find out how it's implemented, or talk to your vendor and ask your vendor if you actually need a license or you need maybe a software upgrade or something like that. But there are some features which we noticed that are available in other vendors and they're not available in other vendors. And these are the features that will actually enhance your deployment of IPv6. So the advice would be to start early, check whether your vendors can support these features. And if they can't support these features, then you need to make a formal feature request to them. Some vendors take even up to 1.5 years to come up with these features. So they have the R&D, and I'm sure if other vendors have implemented it, this is something that they should also be able to implement.
Thank you so much, Samuel. A round of applause. The next speaker will be